Good afternoon. Welcome to this PyCon afternoon session. We're going to hear from Filipe Fernandes about conda and I guess some of the history, perhaps.
Yep.
I'm looking forward to hearing about it. Thank you.
So just before I start, I would like to thank PyCon organizer for everything. This is really an awesome event, and I'm very nervous to be here under this light and in this big room. So if I faint, anyone can come up here and just read the speaker notes. Everything is in here. I'll probably run too fast because I'm nervous. And so if you are really interested in this, try to find me in the corridor so we can speak more later. And because English is not my first language, there's a big chance that you're not going to understand what I'm saying. So I really wouldn't want to be the person doing the live captioning. So before I start, a show of hands. Who here uses conda? Awesome. And who here knows about conda-forge or used conda-forge before? Oh, that's even better. And who here contributed to conda-forge in a way, like a package, a PR, or opening an issue? Not so much. So that's what I want to change. I mean, I'm here to actually tell you guys that it's a community effort and you are all invited to participate. So that's why the title of my talk is Community-Powered Packaging conda-forge. Just before I start, a little bit of who I am. My name is Filipe Fernandes. My Twitter, GitHub, and everything is OCEFPAF. I'm not a developer. I'm a physical oceanographer turned into a developer. I'm a scientist, not a data science, which is the buzzword lately. I like to throw electronic instruments into the salt water of the sea, hope they come back with data. Usually, this is what I do for a living. Like, the whale is not always there. It's only the one picture nice picture that I had. So right now, I'm working for NOAA in an organization that's called IUS, the Integrated Ocean Observing System. IUS break the US into just several smaller regions. And the reason why I'm telling you guys this is because all these regions have universities, 30 companies and individuals that are acquiring data, oceanographic data, or they are creating data via models, and they're putting that data online. And all this pipeline is processed mostly with Python or analyzed with Python. And you can imagine that such a big organization with so many moving parts, like there are 11 regional associations, 17 federal partners. We are using several different formats to store the data, NetCDF, HDF, 4 and 5, CVS, and anything that you can imagine exists there. So how can we actually share our scripts, our Jupyter notebooks across all this community? It's virtually impossible. Like, some people use Windows, some people use OS X, some people use Linux. And if I send someone a Jupyter notebook that loads this data, the first thing they're going to complain, oh, import error, oh, I cannot install this or I cannot install that package. So it's hell. Software deployment in this scenario, it's totally hell. So this is how I define the problem. The scientific Python community always wanted a cross-platform package manager. Cross-platform is very important for us. Like, we cannot think that everybody has a Mac or everybody uses Windows or everybody's going to use Linux. Even in the Linux world, things are not really homogeneous. Like, there are different distributions, different ways to install things, like apt-get, your yum to get your headers and everything. It's very complicated. So we need a single cross-platform package manager. And we also wanted to not require elevated privileges. Like, I'm talking about a government agency. Not everybody can sudo things. They are very limited on how they can install packages. So we need things that can live on the user space. And we needed to handle every type of packages, not only Python packages, right? Including Python packages that depends on third-party libraries, on C libraries, and et cetera. And if we have all that, we can actually use Python as an awesome scientific tool that we all love. So just a little bit of history before I go into the actual meat of the talk. Pip before wheels. Who here remember how Pip before wheels was? Nightmare, right? You're going through hell. Like, how can I get the headers? How can I get the libraries that my Python package that wraps something needs to work? And if you're on Windows, it's even worse. Like, Windows actually has a very nice open source package manager called Chocolatey. Does anyone here ever use it? Just a few hands, yeah. So you can see, just by 3 hands, you can see that people don't even know that about that too much. And after that, we got the distribution area. Like, everybody was packaging whole Python distributions and giving them to you. We have the MFOT Python distribution. We have the Anaconda distribution, which has Conda in it. We had the Activate Python, Python XY, and many others. But distribution are pretty much like those Bronze Age tools for carpentry. They all look alike, and we don't really know if all the tools that we need are there. Like, if you need anything that's not in the distribution, you are back to hell. You can't really solve that problem very easily. Sometimes it's even worse. I met people who had 3 to 4 distributions for different tasks. Oh, I'm doing GIS, so I have the ArcPy distribution. Oh, but now I'm reading NetCDF files, I have the EPD distribution, and so on and so forth. So it's even worse, in fact, if you have more than one distribution installed. After that, we had Conda, and the chance of publishing your binaries online on the anaconda.cloud. It's what I like to call Conda in the various third-party channels. To me, Conda in the various third-party channels is pretty much like that. If you're an expert and know what you're doing, you can get away with it, but the chances of having a broken environment with broken libs, it's really, really high, because you have no idea how that binary was compiled. If it's going to be compatible with the other binaries that you have on your environment. You have no provenance on those binaries. Like, how did the guy compile this? I mean, do you trust installing a binary out of the blue from online on your machine? Like, it's not signed. You have no idea how it was compiled. You have no idea what's in there. So about this time, some companies, not really companies, some communities start organizing themselves and in kind of a ring of trust for channels. My community, we created the IUse channel. The UK Met Office created the SciTools channel. Some people created the BioConda channel, where they had all this biological stuff compiled, and many other communities. So things start organizing by themselves. And then people introduced wheels. It's awesome, right? Who here doesn't like wheels? Just one hand, yeah. I can get that, I understand, but still, it's awesome, right? We can do everything now. We can just publish our binaries on PyPI and pip install anything, right? We are happy, right? No, we are not that happy. There are many problems with wheels. The first one is that PyPI is a publishing platform. So if I'm the author of a library and I own that namespace and I don't want to publish wheels, you can't do that for me. You need my permission to do it. Also, if I want to do it, it's not that easy. All the boilerplate to publish wheels, it's online, it's open, but it's distributed in many different places. It's not that easy to just, build binary and put it there, unless it's a pure Python package. And the worst thing for me is that many packages, they have some compiler flags. And by publishing a wheels, you have only one option, and you hope that's the best option. But what if you need NumPy with Atlas and not OpenBLAS, or with MKL, or whatever library that you want to link to? You don't have that option. I mean, you have only one binary. And what's worse is that some software developers, they don't want to maintain wheels. It's too hard for them. They just don't want to publish. Like GDAL is one of those. Unless you have the headers on your machine, you can't pip install GDAL. So long story short, packaging is not easy. We still have trouble installing our machines, even with pip and wheels, even with conda and various third-party channels. The scenario is even worse if the Python library uses C types to access a C library or a C++ library. It gets even worse when it has a compilation step like Cython or Fortran. Like my word Fortran is alive and well, unfortunately. And on Windows, I mean, come on. We don't even know how to find VC vars talkpath. So yeah, I found myself doing that a lot, especially on Windows. So let me just take a step back. Even though almost everybody raised their hands on what is Conda, I just want to give my view of Conda. It is an open source tool, and it was widely adopted by the scientific community. From their own web page, package everything and share your repository with your clients or colleagues. Now, why the scientific community adopt Conda? Why we didn't adopt apt-get or yum or chocolate or brew? Well, the main reason there, in my opinion, is because in actually my community, if I adopt apt-get, I have to tell everybody, you need to use Ubuntu-derived distros. If I adopt yum, you need to use Fedora-derived distros. And if I adopt chocolate, everybody needs to use Windows. So we can't really do that. And why we can't use pip and wheels? That's another problem that's very specific to the scientific community. Like I said, it is going to be a canonical binary compiled with those flags and those options. If you need anything that's not there, it's not possible. Or, I mean, maybe it can be possible. You're going to be adding layers and layers of complexity to wheels that maybe PyPI maintainers don't really want that. As of today, I don't think that exists. So another step back just to explain what is a conda channel. A conda channel is similar to a Linux repository or an app store. It's where you go to get your binary. Right now, the only canonical place to host your binary is on anaconda.org, because Conda is a tool created by Continuum. They also gave us free cloud storage, so we can put our binaries there. Although it supports anything, if you want to host it locally on your machine, if you want to host it on an intranet on your company, or if you want to create your own cloud and put your binaries there, you should be able to do it and just point to a different URL. And then we can upload our precompiled binaries there. So, like I said, packaging is hard, and that's why you shouldn't do it alone. And this is where I actually get to the meat of this talk. I mean, what is conda-forge? Conda-forge is this. All this work that we have to do for packaging, all these communities, let's join together and let's do it together. So how is conda-forge different from all those third-party channels? First, we try to call on other communities and put everybody under one organization on GitHub. And then we have all these recipes under the same umbrella, so we can discuss, we can talk to each other, we can have standards for the recipes. Then we unified everybody into one build infrastructure. I'm going to talk more about the build infrastructure later, but I'm not going to be compiling things on my machine or on someone else's machine. We're going to be compiling this on the cloud with a set of rules and configurations to standardize all the packages. So basically, this is the idea behind conda-forge. We want to be one single channel to rule them all. So you don't really need to go to other third-party channels. Basically, conda-forge should have everything that you need. So I've been talking how we put these binaries online, but how we build these binaries. They're built using recipes. They're called conda recipes. And they're very similar to spec files who are familiar with RPMs. It's basically just a set of instructions that the machine will use to create a binary. This is an example that I got from the pandas recipe. We basically have the name, the version, where we're going to download it from, a checksum to check if the download is fine, and a command that we use to build. Panda is relatively easy. It's just Python setup install. If it's a non-Python package, we can put all that in a separate file that we call build.sh, and some metadata on who is maintaining that, and the license and everything. Now, the infrastructure, and I really want to take some time to explain this. All conda-forge recipes are hosted on GitHub. We use AppVeyor to build for Windows, Travis CI to build for OS X, and Circle CI and a Docker image to build for Linux. And just a few numbers on the community. And I like to say that this is outdated daily because the community is growing so fast that I got these numbers 5 minutes ago, and I'm pretty sure they are different right now. We have 458 people. We have more than 2,000 teams, and we have more than 2,400 repositories. These are the packages that we have. The teams reflects directly the number of packages that we have. We have one repository for every package. How can you use the channel? You basically do, you add the channel to your configuration, or you can just install using the -c conda-forge. And how can you help us? How can you help the community? You can help us by reporting issues on the packages, updating existing packages when they're outdated, adding new packages, reviewing recipes. This is a perfect example, in my opinion, on how to report issues. This guy had a problem. He just put all the information that we need there, versions, the platform, the error, and what's best of that example, I have a script to reproduce it. So that script becomes part of the package tests later. So this never resurfaces. Updating a recipe is pretty easy. You bump the version number, and then you change the checksum. And this can be done using a PR, via PR. So if you're familiar with GitHub, you can help us right now by just sending PR to update your favorite package. Adding new packages is a little bit more involved process. We have one point of entry that's called staged recipes. This repository is where you send a new package. This new package is reviewed by the community. And once that package is merged, it will be automatically created a new repository with only that package and with the person that submitted as the maintainer. So if you submit a package, you have full control of that repository later. This is just one example of a PR to staged recipes. I was adding a package called those, and that creates a feedstock, which is this individual repository that was created later. It's basically a repository with all the boilerplates for Travis CI, for Circle CI, and for AppVeyor to build your package and upload the binary. So you don't have to worry about that. Everything is automated. All the tools that we use to automate this process lives in a tool called conda-smith. And conda-smith can create the repo automatically, can link the recipe automatically, and can create all the boilerplate for all the CIs. And the last step that someone can help us is reviewing recipes. This is a little bit easier, but requires some experience because we can't automate everything. So, and it's also the most demanding human time activity in conda-forge. So if you're an expert in recipes, we really would like you to take in a look at the recipes that lives in staged recipes. We really need a hand there to merge new packages. Just a quick look under the hood. Like I said, conda-smith is a tool that we use to link, re-render, and create the feedstocks. We use Heroku services to run all the automated stuff. And this is probably an interesting part. To assure that all the packages are consistent with each other, we pin certain packages to key versions. And because we cannot propagate this pin manually because we have more than 200 packages, we have a tool that does that for us. Just a few examples. This is how the linter works. Like this person here submitted 4 recipes, and you can see that all the problems with the recipe was automatically commented on the PR. Like it was missing a summary, it was missing a build number, it was missing a checksum. conda-smith generates the boilerplate using Jinja templates, so it's pretty easy to hack into and change the boilerplate if you have to. This is one example of how we use those templates to update the feedstock, which is basically the whole CI configuration. In this case, we changed the Docker image, as you can see over there, and we removed a pin that we had to conda build. This is all automatic. If you're the maintainer of a feedstock, all you need to do is to click merge when you see a PR like that. And this is another PR that shows how we update the pinning. In this case, we change the pinning of HDF5 and libnetcdf, like we updated from 4.3 to 4.4. Again, this is all automatic. If you're the maintainer of this feedstock, all you have to do is hit merge. The pinning basically is a dictionary that we update every now and then. By we, I'm saying the conda-forge core members, and we have open meetings to discuss what to do and how to do it. So these conda-forge core members, who we are, I mean, we are basically a list of volunteers. No one is paid to be there, and it's actually, the graph is cut down here, but we have way more members than those that are shown here. But why we're doing this? Why not? Why can't we just, upload this, upload binaries, upload wheels to PyPI? Basically, because what's something that I already said, PyPI is first come, first served as a publishing platform, so we can't change anything that's already there. In conda-forge, you can. You go into the recipe, you see how that's built, and you send a PR to change it. And anyone can do that. You don't need to have the rights to that package namespace on PyPI. Another problem with building wheels to PyPI is that everything is decentralized. In conda-forge, everything is centralized in one GitHub organization. So if you hang around long enough, you're going to learn a lot. Like I learned a lot about packaging just by, being part of that community. But what would be the dream? In my opinion, the dream would be to use conda-forge to upload wheels to PyPI. So that's probably a long-term goal. If you want to know more, the two best pieces of documentation were not written by conda-forge members is the Wes McKinney blog post on conda-forge, the CentOS moment. There is a blog that we publish on the Continue.io. There is a really nice blog post by Jake van der Pla on conda myths and misconceptions, where he explains way better than I did here some of these topics. And a Talk Python to Me episode that's also pretty good. I would like to take questions now, even though I have a few more slides in case the question hits exactly what I think you guys are going to ask.
There are mics in the there are mics in the aisles, I think. So if you have a question, walk up to a mic and state your question. Can you walk up to a mic?
Yeah.
Oh, you are. Okay, sorry, I didn't see it.
So why is it so hard to build wheels with Conda? I'm tired of building wheels.
Well, here's the thing. If you are an expert packager, it's not that hard, but it's hard to do that as a community. If you build wheels and you decided, for example, netcdf for Python, which is a wrapper to the netcdf library, and you decide to use the netcdf library 4.3, but I need 4.4. It's hard. How can I access you and ask you to rebuild that wheel and recompile it? And then I needed to have the OpenDAP flag because I need to access data online. And then things get really hard. I mean, the communication gets really hard because it's going to be only the developer creating the binary and putting on that platform. The difference in conda-forge is that it's not the developer, it's the users. Like we have about 5 maintainers for the libnetcdf, and any user can just go there on the feedstock, open an issue and request a change, or just send a PR to fix any problem. So it's not that it's hard to build wheels, but it's easier to maintain binaries in the conda-forge model, in my opinion. Maybe I should phrase that like that.
So you're saying it's a PyPi's problem, that it doesn't allow for several wheels in a version and correctly. Thank you.
Thank you.
So I've installed packages from different channels, and they'll sometimes conflict or have different dependencies that will conflict and break. Is there some sort of guarantee that if you install from conda-forge, that all of the packages will play nicely together?
Yes.
Okay. How do you do that? How do you do that?
To be honest, I mean, I can't really say yes, kind of. It may be broken every now and then, but then please, if it's broken, report the issue and we're gonna try to fix it immediately. And how we do that, with that pinning bot, it's part of it, and our build infrastructure is uniform. So we always use AppFair, TravCI, and a same Docker image, and everything is hosted, all the configuration, the Docker file, everything's hosted on GitHub, and it's open, and it's trackable. So even though we do face problems and we do break things, it's very easy to trace back to them and fix them.
You mentioned several times the issue with choosing a compilation flag. How do you choose compilation flags?
It's kind of a dictator thing. Like if I'm the maintainer, I want this, I just put it in there, and then the community starts shouting at me, hey, remove that flag, it's bugging me, it's breaking my workflow, and we start a discussion. It's a community effort. We need some discussion.
Hi, are there any plans to go any lower level? So for example, like you're using an older libc version or you have a VC runtime that's too old. You say you have like sort of 3 environments, but is there any plans to basically add dependency tags in your sort of compiled packages for like, oh, you have to use, libc, whatever, 212, not 217 or whatever?
Yeah, that's a very good question. I was afraid that's going to show up. I mean, we are limited to a certain set of versions that we can support. Right now, we're trying to use a really old CentOS Docker image to be forwards compatible. But everybody needs new C++ features, so we need a newer GCC. It's basically the same problem with the pinning, like I said before. We can create different channels and different Docker images and have different versions, but that's overly complex right now. Maybe in the future we can do that. What we can do is we start a discussion, open an issue. Hey, I really need modern C++, so I really need a modern GCC. And we start discussing from there. All the discussions on conda-forge are open, our meetings are open. So if you want something that's not there, just attend the meeting and request it. And we're gonna start working towards it. No more questions?
Yeah. Is it possible to use conda-forge, the environment, the tools, and the methodology that you're using to like install that locally and use it if we're in a situation where we can't be doing it from a web-based thing where we need to be building our own on our own hardware, but use the infrastructure?
I'm not sure if I got your request correctly. Here's what I understood. If you want to use conda-forge, but you don't want to install the binaries from anaconda.org, right?
Well, I'm interested in how you're doing that, but we would basically need to do it ourselves. We would need to do our own builds, our own hardware, with our own repositories.
That's perfect. We have one repository that aggregates all the recipes. That's called the feedstocks with an S repository. And actually, in government, people do that. They can't use the binaries, but you can use our recipes. You can use our infrastructure to just recompile everything and have your own local channel. And we actually have some people doing that. At the UK Met Office, they do that. At NOAA, some people do that.
So, really quick, one last question on compile flags. And actually, specifically Wheels and the problem Wheels has with Linux distributions. Take something like curl, libcurl, one of the most common libraries probably used out there. Under Debian has some flags that are required. Under Red Hat has other flags that are required. Do you support that? I mean, are we back to fighting over which distribution is best?
Sorry, I'm not really sure I got your question.
So, at the flag level, do you support different distributions of Linux? Or is it like, because Will, you have the many Linux, and everything fits in there, and if you have different flags on different platforms, then you don't have a wheel.
Well, we are somehow also limited like that. Our Docker images are many Linux. The only difference from the many Linux is that if you did something different, you can open a discussion and we can see what we can do. With many Linux, unless you're part of the people organizing that, I mean, it's open as well. You could open a app and request to change it and request something different, but it's more bureaucratic and slow. In conda-forge, hopefully, it's less bureaucratic and faster.
Okay, thank you very much.